Okay, this is my home, not really a distillation column, but a still. I built it primarily for separating ethanol from water. The general construction is fairly simple. We'll start off with the structure. Um, so this is just a 2x4 and plywood base. It goes up and then an arm just to hold up the main bulk of the column. The actual heating component is, as you can see, just a hot plate and a pressure cooker with a hole drilled in the top. The column is a little bit more complicated. It is a 3/4 inch copper pipe that goes into a T-joint and then a U-joint, and all those soldering connections are made with lead-free solder and lead-free flux, so it's technically drinkable. I doubt that I will ever do that. I just don't know if I trust everything that's in here. And then the heat exchanger I'll go into a little bit more depth in just a little bit. The seal right here is pretty poor. That's something that I'd like to definitely change. And then this cap on here isn't actually soldered in. I plan on putting a temperature gauge there so that I can see what the temperature at the top of the column is. I had just turned it off actually, but it looks to be putting out a little bit more right now. The flow is pretty good. I'm putting a lot of heat in and having to take a lot of heat out, and I'll kind of go into that again in a minute. But the flow is pretty good, and it looks like the water is pretty clear, so I think I am just running water right now. So just to kind of test it, because water boils at a much higher temperature than what I'm looking to get out of it. So this is more of like a stress test than I think a more real life application. But I've been running it for about an hour now, and this is how much water I've been able to produce, or at least been able to move up through the system and then into here. The heat exchanger is probably the most complicated part of this, so we'll start off with the construction. We start off with a 3/4 inch copper pipe, which gets reduced, and you can't see it because it's surrounded right now, but it gets reduced into a 1/2 inch copper pipe, and then it comes back into a 3/4 inch copper pipe. And then outside of that, I've built a 1 inch copper jacket with barbs on it that allows water to run in and out of the system, just like any general water jacket heat exchanger would work. The pump driving it is just a $10 Amazon pump, runs off 12 volts DC. It seems to be doing the job. What isn't doing the job though is the sink, which I just have as a water bottle filled with ice water. Every 4 or 5 minutes the ice melts and the water starts to heat up, actually surprisingly fast. So I'm going to need a much better solution for basically just a much larger heat sink with a lot less energy density in it. A few improvements I'd like to make to this system is getting a temperature gauge on the inlet hose and a temperature gauge on the outlet hose, and then that way I can calculate the temperature differential by using the flow rate and the specific heat of water. Pretty simple. That, or I could just use time and then measure the temperature of the bath and then see the energy that way. I'm not sure exactly what I'm going to do yet there. Other improvements I'd like to do, obviously you can see that this is kind of leaking a lot, so I'll need to do something there obviously. And then also I'd like to put a temperature probe on the bottom of the column and at the top of the column, which allows me a little bit of feedback when I'm adjusting the input heat. So if I'm having a lot of input heat and the bottom of the column is really high and the top of the column is also really high for some kind of separation that I'm doing, then I can change it. Or consequently, if I'm not putting enough energy in and the temperatures are too low, and I'm not moving enough of the process, then I can increase the temperature. Also help me tune for whatever I'm separating. I don't plan on using this to separate anything except for ethanol and water, but if I did, I think being able to know exactly what my temperature differential on the column is would be very helpful. Other than that, those are just some basic improvements that I'd like to make, mainly getting some temperature probes so that I can actually do the thermodynamic calculations, and then also improving the